What are polar and non-polar covalent bonds? I'm glad that I wrote down that, because I'm actually going to, well, not really cheat per se, but I'm actually going to copy and paste what we actually discussed earlier. We're going to go all the way over there. Why? Because I feel like this is actually, I would consider this gold. So I know we discussed electronegativity, so I'm going to do here is literally just copy this section. This is also for my notes as well. In fact, I guess I'll keep this stuff about ionic. So let me copy that. Let's scroll now back down to question 26. Okay. And let's actually still write down the question. What are polar and non-polar covalent bonds? Okay. So with that being said, let's paste down what we had. Okay. So electronegativity difference, as discussed earlier. Man, okay, I'm glad I actually was paste this down. Is that it increases from the bottom left to the top right, fluorine being the most electronegative and francine being the least electronegative. Non-polar covalent bonds fall in this range of electronegativity difference. The most typical one you'll see actually, at least if I remember correctly, is carbon and hydrogen. Those are like, I guess, the most type of non-polar bond you would see. So carbon is 2.55, and hydrogen is 2.20. So let's actually change this then, because I believe it's actually 0.4, not 0.3. So that's embarrassing. Yes, so 0.4. Reason why I made this quick change is because you notice that carbon is 2.55 and hydrogen is 2.20 and 0.35. But I know for a fact, based on my previous knowledge, that hydrogen is known, hydrocarbon actually, that bond is known to be non-polar. So I'm just going to fix it here as well, just to keep things consistent for future notes. And yeah, so yeah, now we know. And there's also lists you can also find, not only your textbook, but actually in your textbook it should actually break down the electronegativity difference, because these are established in literature that this is what they usually refer to as being the cutoff for different types of bonds. So now the question is asking, okay, what are polar and non-polar covalent bonds? So non-polar covalent bonds means that overall, right, when you have like carbon, hydrogen, okay, you wouldn't have a net charge, okay? These would be kind of equal. It wouldn't be leaning towards either side because the difference is 0.35, okay? Now if you had carbon chloride, okay, chlorine, okay, is 3.16 and carbon is 2.55. So 0.61, not the greatest difference, but it's big enough to where actually we actually use a sign here, okay? This means that it's gonna be more negative and that's gonna be more positive. We don't do it like ionic compounds where we just say like NaCl, whereas Na is positive, Cl is minus. We actually break it down like that because we're saying that it has a polarity, a negative polarity on the Cl and a positive polarity in this carbon, okay? So negative in the chlorine, positive in the carbon. That's usually how we indicate a polar bond, okay? And this right here, we actually would even have this because exactly there's no real polarity between C and H, okay? And as I mentioned here, the difference in electronegativity develops partial ionic charges due to exactly unequal share of electrons. Point being is that the greater the electronegativity difference, the more polar it is, not the more ionic it is. Because ionic, as we discussed, it has to have a certain amount of electronegativity, plus the fact that it's a non-metal and a metal together. It needs those two criteria. But you notice that most things that do have a electronegativity difference greater than 2.0, it's mostly a metal and a non-metal paired together. Okay? So methane is a good example of a non-polar covalent bond because of the fact that the CH's, that bond is not polar. Okay? Water is an example of a polar covalent bond because not of the lone pairs, but specifically the bond between oxygen and hydrogen, that one, 2.20, and oxygen, based on the periodic table, is 3.44. Okay, so that's 1.24 difference. So just like how we drew the other one, it's going to be more negative on the oxygen, because it's always going to be more negative to the one that's greater in electronegativity, because as the name implies, electronegativity. So exactly, it's going to be more negative towards the oxygen. But yeah, so this is really the breakdown of it, and that's the oxygen hydrogen bonds in water. Now if you want to discuss whether the whole molecules are polar or non-polar, as I mentioned earlier, polar molecules just depend on how it's all balanced out. For example, and I'll say this example again, carbon tetrafluoride is a non-polar molecule with polar bonds. Okay, because Cl, they're all polar bonds, they have that difference. It's all electronegative in each corner. But because they're all evenly spread out, there's overall no net pull. That's a little bit of physics, you know. There's no net pull towards any direction because all the forces cancel out for a net of 0. So this is an example of a non-polar molecule with polar bonds. Okay, so correct. Okay, so now question 27. Like last session, we are going to 30 questions.